today we're going to talk about like and unlike terms. And this is so that when we start doing the adding and subtracting, you'll be able to determine which terms go together and which ones do not. So before we can start, let's just do a little bit of a review on our zero principle. All right? Whenever you take and put the same number of positive tiles and negative tiles together, they create a zero. Now you could do this in pairs or you can do this in groups, it doesn't matter. But if you take a look what we've got right here, you'll see I've got a white tile and I've got the dark tile, the positive and the negative. You put those two together and they're going to form zero, which essentially just means that they disappear from your equation. Same thing here, this is a positive x and a negative x. Put them together, you get zero. This is a positive x squared and a negative x squared. You put them together and you also get zero. Okay. Now in polynomials, there's times that the terms that are there haven't been combined or put together. So you may have, in terms of a symbolic, just in terms of numbers and variables, you could have like 3x squared plus 7x squared. Right? And what we need to do is to figure out whether you can put x squareds, x's, or constants together with each other and how it's done. So let's take a look at the following tiles. This particular tile right here is a positive x squared, negative x, and negative x. And these four tiles can be written in a variety of different ways. Okay? The first one could be x squared plus x squared minus x minus x. Or what I could have done is taken and done this. Put these two together and say 2x squareds minus x minus x. Or I can keep these separate, x squared plus x squared, minus, and put those two together and get minus 2x. And of course the final one would be to have 2x squareds take away 2x's. But you'll notice here that every time I combine the x's together, here the x squareds, you see x squared plus x squared, there's two of them. And remember, that's what our coefficient 2 means. This 2 in front of the x squared tells you how many of the x squareds you have. If you look at the tiles, you'll see we have 2. Same thing down here. Negative 2x means we subtract an x and an x. We're going to take away 2 of them, which means we're subtracting 2 x's. Okay, in this case we have a combination of tiles in which you can use to it's called the zero principle. Now I split this up into 2 steps, but when you're doing it, you'll model it, draw it once, and then you'll just circle and take away whatever cancels out as we term. All right, that's the term we use when we're talking about zero principles. When something forms a zero, we say it cancels out. So take a look at the first one here. You'll see I have an x squared, which is positive, another one. Here's an x squared, which is negative, positive x, and of course 1, 1, 1. So the things that can combine here are the shapes that are the same. So these are 2 big large squares, so they can go together. You'll notice nothing else here can go together because they're all different shapes. So what I would do is you would circle this on your tiles and you zero it out. Right? Now what that leaves is you now only have an x left because this is now gone. And then also these things here we haven't done a thing with. So this is still an x and a 1, 1, 1. So we still have that left over. Now when we put them all together, we'll have an x squared. We have one of those. We have 2 x's here, so that's 2x. And then I have 3 1s, which is 3. They're all positive, so you'll see they're all got a plus in front of them. Okay, sometimes it's not so pretty. Things are all over the place. So what I want you to do this time is I want you to do the canceling and stuff. Now you can redraw them down below. I'm going to show it down below so I don't wreck my drawings, but if you want to do the work up here, go ahead. I want you to take and pause the recording, circle and arrow out to a 0 everything that cancels. Okay, well first off, if you take a look, we've got x squared, and negative x squared. So this x squared, which is negative, can cancel with either one of these two, right? So I chose the one on the top and the bottom, so those are going to go to 0, they're going to disappear. Okay, now I still have to talk about the x's here. All right, now this x squared, which is negative, could cancel with any of them. So I just got to circle whatever these two are and cancel them out. Oops, I did the wrong one there. Here we go. So I've canceled this out. You see those two are going to go to 0. And the last one would be to choose a negative 1 and a positive 1. And they will cancel out also. So this is what your canceling should look like. Now you may not have chosen the positive and negative squares x squareds here that I chose. You may have chosen this one and that one. Likewise over here you could have chosen this one and that one. Or over here you could have put this negative with this x, or that x. It doesn't matter because when you're done, you're going to have an x squared left over. There's your 1. And of course there's your 2 x's. And when we turn this into symbolic, which is your letters and variables, sorry, variables and numbers, we have 1x squared there. All right, there's your x squared. I've got 2x's, so I'm going to add 2x. And I have a negative 1, so I'm going to subtract a 1. So there is our polynomial. Okay, remember, my coefficient on the x squared is a 1. My coefficient on this x term is a 2. And the constant is negative 1. I'm dealing with a variable x. And remember, this is 3 terms, so that makes it a trinomial. All right, I want you to pause the recording, and I want you to cancel out what cancels out here. All right, well, I'm just going to start taking things here. I'm going to take this one and this one, put them together, which is going to give, that's going to go to 0. Up top here, I'm going to take this one and put it with that one, so that takes care of that. And over on these x's, I'm going to take this positive x and this negative x, and I'm going to circle those. Now, all of these should have an arrow, I didn't put mine in, which goes like this, and you should have, oops, sorry, not an arrow, which have an arrow which tells everybody that they're disappearing. Right? Now, what's left over when you do this is I got the 2 1's, I've got the 2 negative x's, and I have 1x squared. Now remember, we always, when you put a polynomial, write it down, you do it by degree. So this one's going to be first, so I'm going to start off with a negative x squared. All right. Now I'm going to have negative x's, and there's 2 of them. And I'm going to have positive 2 there. So there we go, positive 2. Now, tiles. Tiles are great. They help us to visualize what's going on, but they have a problem. And you take a look right here, you'll see very quickly. I don't think any of you would want to take this equation right here and try to draw the tiles for it. First off, it's kind of ridiculous because there's so many. Now, do you get equations that have big numbers? You definitely do. Right? But you don't have to have something even extreme as this. Even if you had just like 5x squared minus 23x plus 158, right? Just having simple ones, I don't think you want to put down 158 little tiny squares, right? And have 23 rectangles, and over here have 5 big ones. You don't want to do that kind of stuff. It takes too much time. So we have to change the way we're doing it, and we're going to turn to what we call the symbolic method. We're still going to use tiles a little bit to help us explain the symbolic method, but it's very straightforward because you've been doing variables and stuff in grade 8. So you should be able to realize that, you know, these are things that they're quite common, and you've seen them and you now know them from the lessons we've done previously. Right. So we could draw the tiles, but by now you should be able to tell which terms can combine. Now, I've purposely made this x squareds, x's, and constants. So the first ones we can put together are the 2x squared minus x squared. There's our first thing we could put together. We can put together the plus 2x and the plus 4x. And we can put together the positive 6 and the negative 2. All right? So for the first part, we have 2x squared minus x squared. So I have 2 large squares. Now those 2 large squares, I'm going to take away one of them, right? See, we have one which is 2 which are positive, one which is negative. So the big one, positive, and the big one, negative, cancel out. So you're left with a single x squared left. Now remember, this x squared has a coefficient. It's a 1, right? So 2x squareds, remove one of the x squareds, leaves you with just an x squared left. Now let's take a look at the second one here. All right, this is what we're looking at, 2x plus 4x. So you would have basically 2 positive rectangles here, and you'd have to take, you would have 2 positive rectangles from 2x squared and 4 positive rectangles from 4x. Okay, that's what I was thinking. For a second there, it looked like I had some problems with my language, but no. This one here gives you 2x squareds, and this one gives you 4x squareds. So when you put these two together, 2x's and 4x's gives you a total of 6x's, and they're all positive. So this looks like 6x. Now for the third part, which is our constants, all right, we have 6 take away 2, or a positive 6 and a negative 2. So 6 positives and 2 negatives would give you 4. And they're all positive, so we'd have left over 2 positives canceling out with 2 negatives, and that will leave us with 4 positives left over. So putting this all together, I have to grab this here, and the x, 6x, and the 4x, 4, and there's our job. Now, how am I going to mark this? Well, I'm not expecting you to do all this stuff here. What I'm going to expect you to do is, if this was the question given, right, all I want you to do is to separate them out. So group them together. You do that with brackets. All right. Now, then when you mark this, I'm going to be marking, did you get the x squared correct? Did you get the 6x correct? And did you get the 4 correct? All right. So this part here is going to be 3. This will be 1. And you will always, always, always put down the question. That's never an option. Okay. If you just start with this, I'm going to take a mark off. Right. It's like starting, a problem without having the problem written down. Okay, so let's have a look here. All right, now I'm going to do another one with you, and then after that, you're going to do some on your own. So simplify the following polynomial symbolically, which means we don't draw tiles. So you see here, I've still got these ones grouped: a squared plus 5a squared minus 3a and positive 2a, and a positive 4 and a negative 3. So taking a look at the first grouping right here, that's going to give you 1a squared and 5a squareds. So 1 and 5 gives you 6a squareds there. One large rectangles, one large square plus 5 large squares gives you 6 large squares. Now a negative 3 plus 2 gives you a negative 1. So this is going to result in a negative 1a. Now if you remember, this is 3 rectangles which are all shaded in. This is 2 rectangles which are positive, and 2 of these are going to cancel out 2 of those negatives, leaving us with 1 negative remaining. And of course 4 and negative 3, or 4 take away 3, is 1. So now put them all together, you get 6a squared minus a plus 1. And you notice I did not include the 1 here. That's usually what we do. We don't include the 1 there. Everybody just knows that there's a 1 there. Okay, now these ones are all mixed up, but I'm going to let you try this, okay? So pause the recording and show me the work, and we'll see how it goes. Okay, well the first thing you do when you look down here is you're going to try to figure out which one of these is the ones which are the same. And you notice I've got a b squared here, I've got a b squared there. So these are my two b squared terms, minus 3b squared and positive 2b squared. So there's my first one right there, 3b squared plus 2b squared. Well, 2 big squares from 3 big squares which are shaded in, so 2 cancel out, leave me with a b squared. All right. Now, the next thing I'm going to look for is I'm going to look for my b's. One there, and one there. So I've got 3 this time. All right. So this is going to be positive 2b minus 4b. Don't forget that has to stick with it, and positive 2b. So this is what it looks like. 2b, take away 4b plus 2b. A 2b, a negative 4b, and a positive 2b. 2 and negative 4 makes negative 2. And negative 2 and 2 means you get nothing. So you would have what's called a 0b. Now, you don't put this down. All right, you just don't. If it's gone, you leave it. Next one, I'm going to have to take and find the constants. And I've got a positive 3 and a negative 1, and as I go through here, nothing else is there. So my positive 3 and negative 1 is 3 take away 1, and that's 2. So taking the negative b squared, this goes away, and the 2 gives us negative b squared plus 2. Okay, how would I mark this? Well, I'll be looking at, obviously you have the question down, and then you're going to deal with this question there, this question there, this question there, and that question there. So you can see it's really easy, 4 marks. Okay. The next thing we're going to do is we're going to take a look at something that happens in terms of perimeter. Now remember, perimeter is the distance around the outside of something. And on your achievement test, they always have these questions, so you better pay attention to it and learn it. Now, the idea here is that this rectangle, this square right here is an x squared. Now the reason it's an x squared is because it has the dimensions which are x by x, right here. There's an x, there's an x, there's an x, and there's an x. And if you remember our rectangles, when we drew them before, they were rectangles, right? And I always try to make them about the same size as what would be here. So it's like there's an x there, all right? So this is x, x, and x, and x. So if I want to make the perimeter, you go around the outside here and you start adding things up. So this is an x plus an x plus an x plus an x. So my perimeter is going to be x plus x plus x plus x. And when you put them all together, it's going to be like 4 x's. There you are. Now, what's the perimeter of this one? Again, as you start to go through this, you have to take a look at what are the blocks here. What are the lengths? Well, this here length here, that's an x. This length here, that's an x. This length here, well, it's the same size as one of the small squares, so that's a 1. This here is the same length of an x. And again here, another 1, and an x, and an x, and an x. Now when you add all of these up, right, you're going to have 1, 2, 3, 4, 5 x's, and, sorry, 6 x's, and 2 1s. There's your 5 x's, 1, 2, 3, 4, sorry, 6 x's, 1, 2, 3, 4, 5, 6, and there's your 2 1s. So that leaves us, when you put them all together, 6x, 1, 2, 3, 4, 5, 6, plus 1, 2. There we go. 6x plus 2. 1, 2, 3, 4, 5, 6. Oh, I have 1 too many. All right. This one here shouldn't be there. Counted too many. But it is 6x. Okay. You take this one on, okay? What is the perimeter of this one? So pause the recording, write the information around the outside, and then show me the addition and then your sum or your simplified polynomial. So do that right now. Okay. Well, the first thing I need to do is I have an x here. 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 And I have an x on this side over here. And I have another x over here. Now the 1s, that's a 1. That's another 1. This is a 1 here. And this is a 1 here. So now if you go around the outside, have I labeled everything? Yes. Now remember, you're going around the outside. Perimeter is the distance around something. So once I've got that done, then I'm going to take and write them all down. So what I did is I started and then went x plus x plus x plus x plus 1 plus 1 plus x plus x plus 1 plus 1 plus x plus x. Okay? So started here and went all the way around. Now, counting the x's, I've got, if you start right here, 1, 2, 3, 4, 5, 6, 7, 8 x's, right? And I have 4 1s. So you should have 8x plus 4. And hopefully you got that. Okay. Simplifying polynomials with 2 variables this time. Now before we talk about what can and cannot go together in terms of x's, we talk about x's versus y's. Now in a mathematical equation, if x equals 7, and you also have y in that equation, y cannot be 7. It has to be everything else. Okay? Everything else, right? So it could be any number, but it can't be a 7. Because if it was a 7, you would just have x and x. So whenever you see different variables, it means x is one number, and a different variable is a different number. All right? So let's take a look here. So frequently, we have more than one type of variable in a polynomial. So it's important that you understand what makes the polynomial different as well as what makes it the same. When the polynomials are the same, like the x's, which are your rectangles, right? They can be put together because they're all rectangles. You just count the rectangles. If they're all 1s, like little tiny squares, you can put all those together. If they're all large squares, x squareds, then you can put them together. But you can't put a large square with a 1, and you can't put a large square with a rectangle, and you can't put a rectangle with a 1. Everything's got to have the same shape and size, right? So in this case here, you can see we have x's. These x's can be combined. And we have y's. These y's can be combined. However, the x's and the y's, I can't put this together, right? What would I say? 4 what's? Is that 4 x's or is that 4 y's? Well, it's not. It's not 4 x's or 4 y's. It's 2 x's and 2 y's. Okay? So you cannot combine variables which are different. All right, let's look at the next example here. So our first one is an x squared. So what I normally do is I start with x squared, and I go down the line. I try to find all the x squareds, and I normally underline them or circle them in some way to keep them separate from the rest. You'll notice I got a 3x squared minus an x squared. Okay, so these ones here, they can go together because they're the same terms and the same degree. Same variables, same degree of 2, they go together. All right? Now, taking a look at x, I've got an x here, and I've got a 4x here, so these ones, they can go together. And here I've got a constant of 3 and a constant of 2, so they can go together. And finally, I've got a 2y squared and a 3y squared, same variable, same degree, they can go together. So what I need to do here is take all of these groups and put them down, and I need to be able to combine them. So separating everything out, this is what I end up getting. 3x squared minus x squared, x take away 4x, 3 take away 2, and 2y squared plus 3y squared. So I have here 3x squared minus x, that's going to be a 2x squared. Sorry, 3x squared minus x squared is going to give me 2x squared. An x which has a 1 in front of it, so that's 1x, take away 4 x's. So if you think about this in rectangles, you've got big rectangles here, they're all darkened in. There's one which is not. One of these is going to cancel with that, leaving you with negative 3x left over. 3 take away 2 is 1, and we have 2y squared and a 3y squared put together. That's 5y squared. Now the last thing we need to do is to arrange these according to degree. Now when you have two of them which are the same degree but different variables, you just do it alphabetical. So this is going to start out with our x squareds. Okay, so I have 2x squareds left over. Now go to the y squareds. There we are, 5y squared. Next I have a 3x. This is a degree of 1, remember, because it's got the x has got a 1 exponent. And of course my constants are last. So there we go. There's your final answer. How am I going to mark it? Well, let's get a different color here. So I'm going to expect you to group it. Well, there's your question. Group it and do it. And if you have to, rewrite it. Okay. Now, when I do the rewriting, I normally mark each individual term because you would have done this, 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 and this as separate calculations. Well, I want you to try this one here. X plus 2x squared plus 5y squared minus 4 plus 2y minus 5x squared minus 4y plus 3. Pause the recording and try this question right here. All right. Well, first thing I need to do is I need to go through this and find out which terms can go together. Well, this is an x squared, an x there. Are there any other x's in this question? No. So I'm going to start off with just an x. There's nothing there. All right. Now, the next question is going to be the x squareds. I have a 2x squared there, going down, going down. Oh, there's a 5x squared, and it's negative. So I'm going to be putting this one and that one together. Now, looking for the next one. What about the 5y squared? Are there any other y squareds here? No. So that's the only one of those. It doesn't go anywhere. All right, so that one's going to be by itself. Okay, constants are next. All right, so I've got a negative 4, and I'm looking for constants, and there's a 3. So these two here, they will go together. Now looking at the y's, I've got a 2y, and I got a 4y. So this one and that one are going to go together. So taking a look at grouping these now, this is what it's going to look like. There's my x squareds, my 2 and my 5. Sorry, I got that last bit mixed up. Get that out of there. All right, and then I'm going to have an x. I'm going to have a 5y. And you can see I've taken and grouped everything together for the math. So I'm going to be expecting this step right there. Let's get rid of that color, make it more visible. I'm going to expect this step right there. All right, now, 2x squareds and a negative 5x squared. Well, 2 minus 5 is negative 3. All right. X doesn't move, nothing there. 5y squared, nothing to add to it, it stays. 2 take away 4 is negative 2, so I have negative 2y here. And a 3 take away 4 is negative 1. So I get 3x squared plus x plus 5y, subtract 2y, subtract 1. And of course, if I'm marking this, you're going to get 1, 2, 3, 4, 5. And of course, this is going to be worth 1. That's 6. So you always copy down the question, and you have 6 marks here. So this question would have been worth 6 marks. All right, last one. Pause the recording and do this one. All right, let's go. Let's see what we got. Well, I have got, let's get a different color here. I'll start with that one. Okay, x squareds. Where are the rest of the x squareds? Going down the line. Oh, there's an x squared. Nowhere else. So this one, see if I can make this work, and that one are going together. Okay, y squareds. Sorry, not y squareds. Y's. So that's a y. And oh, that's got a, oh wait, that's got a y, but this is an x times a y. So that's not a y. This is a different thing together. This is a second degree. Remember, 1 plus 1. So this can't be combined with that. Going down for the rest of the y's, there's a y right there. And looking down here, oh, here's a y. But again, that's an xy, not a y. So these ones here don't combine with a single x or with a single y. You have to have an xy to do it. So these two right here, they're going to go together. Okay, now I've got xy to look at. Well, there's xy there going down through my list. There's an xy. So this means that this one is going to go with that one. Okay, now we have just x's. All right, I got an x. Is there any other x's? Oh, there's a 5x. All right, so I can take and move the x's. This 3x can go with the 5x. And now let's look at constants. All right, the constant. The constant is a -7, so that's going to go with the other constant, which is +2. Okay, so there's my groupings. So my x squareds, 3x squared minus 2x. Here's my x's. Here's my constants. Here's my y's. And here's my xy's. Okay? Now, how you put them together at this step and group them is not important. So you could have had them out of any order. You know, -5xy plus 8xy could have been up here. It doesn't matter, right? Now, what we need to do, though, is we need to take and do some work here. -3 minus 2 is -5. Think of this as 3 negatives, and 2 more negatives gives you 5 negatives. 3x, take away 5x, well, that's 3 positives, 5 negatives, so you're going to have 2 negatives left over. And then the constants here, -7 and a +2 leaves you with a -5. 5y, take away 6y. Well, 5 positives and 6 negatives mean you're going to have a negative left over. So this is going to be -1y or just -y. And of course, the xy's can go together. There's -5 here, +8 there, which means you have 3xy left over. Okay. Now, the last thing we need to do is to do the putting these into a according to their degree. All right, let me get a different color here. Well, the first one, this is a 2 degree, and this is an xy. That's a 2 degree because remember, that's a 1 and that's a 1. So these two have to be first in your line. So you should have started out with -5x squared. All right, now this is pure, so it goes first, okay? 3xy comes next, and it's positive, so there's your 3xy. All right, so that one's taken care of, and that one's taken care of. I now have to take a look at my degrees of 1. Remember, this has got a 1 here, and that's a 1, so these are both second degree. Let's look at our first degrees. Those are your x's and your y's. Now, I told you when you have both x and y, you go alphabetical. So -2x, so this is subtract 2x. That takes care of that one. And -1y, so just subtract y. That takes care of that one. And, of course, we have a subtract 5 left over. So there you go. And of course, if I was marking this, it would look like this. Yep. And then yep, 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 and yep. Okay. Now, just to give you a little bit of a heads up here, if you had made this a positive, because a -5 and a +5 are not the same thing, then that would have been wrong. So do this, get it wrong. This is a -5. So marking this would have been 1, 2, 3, 4, 5 marks for doing all the work. All right. And then over here, 1 for writing down all the groupings, okay? And of course, there. Now, so you could get this mark and this mark together if when you wrote the groupings, you put them by degree first. All right, so we're looking at 1, 2, 3, 4, 5, 6, 7 marks for this question. All right, time for your assignment. Enjoy, and we'll see you in the next lesson. Again, if you have any questions, come talk to me. If not, you can watch this as many times as you need to. Okay, see you in the next lesson.